Welcome to this panel. And my name is Mark Donnigan. I am your moderator. We are here to talk about using the cloud to overcome challenges in scaling video workflows. So as is always my disclaimer, this subject's so vast and there's, we could talk for days, right? So what we're going to do is we're going to structure this, probably the first, 40, 45 minutes. We have some questions and a talk track prepared, and there's no doubt that we're going to, the panel will deliver some really great insights. And then I want to open it up to questions. I don't know if this mic is active, so we may or may not be. It is active? Okay, great. So come Q&A time, then you'll just come and stand up in the center here and use the microphone, and that'll be great. But with that, let's jump in. And I guess, Zoe, why don't you introduce yourself and tell us who you are, your company name, and then we'll go on down and we'll start.
Hi, everyone. This is Zoe Liu, and I'm the co-founder and CTO of Visionular. So Visionular is almost, by July, we're going to be 5 years old. And we mainly deliver video encoding and streaming solutions. And at the very beginning, we provide this software for on-premise deployment. Of course, attending this panel because we are moving toward cloud, and we already started to provide more cloud API SaaS type of solutions.
Great. Yeah. Hello, everyone. My name is Suresh Somasundaram. I'm the SVP of Software Engineering at Sling TV, part of the larger Dish Network family based out of Denver. My team is responsible for the architecture, engineering, and operations of the entire Sling TV product suite. And just to ground ourselves a little bit on the context and background, Sling TV was the first of its kind, born 8 years ago, launching live TV streaming services for the first time in our country. And over time, has evolved into a very large-scale platform delivering live TV streaming services, on-demand services, look back, and a number of other capabilities. We carry about 1,000 plus channels, 30,000 plus on-demand assets, and run on 18 different platforms. You name it, we have it. I'm here excited to be part of this panel.
Awesome. My name is Rob Wilmoth. I'm from Red Hat. We have traditionally been known as the Linux company, right? We are way more than that. We're not, one of my customers yesterday said, this isn't your grandfather's Red Hat anymore. So we focus on cloud infrastructure technologies. I'm responsible for all of the technology architectures for the Americas for media and entertainment as well as cable. So we've kind of cut our teeth on cloud infrastructure technologies based on Kubernetes and containerization and cloud native technologies within the telco space. And we're taking a lot of those lessons learned, reformulating the feature set, and making them ready for consumption for media and entertainment companies.
Great. Let's start by, I think it's helpful. We use the word scale, right? It's, it's required. Every sentence has to have scale in it if we're talking about video. But how do we define scale? Let's talk about what that means from your respective, where you sit in the ecosystem. So I'd actually like each of you to answer that because you're going to have 3 different answers. And I think that'll be really interesting place to start the conversation. So Zoe, since you're to my left, you get to start.
Okay, so talking about scale, and then because it's mainly we learn a lot from our customers. So I have to mention that even though we are almost 5 years old, and we have served almost 100 really enterprise users, customers, and then some of them has a huge amount of data. And then because we have served a very top, for example, in the Indian market, the top short video app, you can imagine that the data, especially for the short videos, and they're huge. On the other side, we have some customers who are relatively small. So we recently got a customer in the OTT, and they are just starting to scale their own business. So they love to have cloud APIs because it's a lot easier for them to get on board because they have more growing volumes of videos. They want to leverage our 264 and HEVC encoders. So you can see that is both of these one, they definitely have a different scales, and the difference is huge. And cloud, everybody talking about scale. So back to our product, I want to use as an example. So for video encoder, everybody knows that the encoder means compression, right? Because every single video, if you capture on the phone, upload to the cloud, for example, no matter whether it's YouTube or Reels or TikTok, those are the UGC, or you watch a football, and then that video usually goes through the cloud doing the transcoding, and then before it is being distributed to many different users of many different situations to many different varieties of devices. So because of this, back to the encoder, there's 5 usually factors to evaluate the encoder: quality, bitrate or bandwidth, and then the encoding processing delay. So that's basically is the turnaround time. And then there's always latency. People all talk about RTCs, live streaming. And the 5th is underlying compute resource, because nowadays everybody talk about cost saving. So we have to be put that in mind. So with the cloud, we found that we have that flexibility and to scale, because some customers said that they have very small volume. They don't want to pay much. And then at this time, you may want for us to provide this solution to do the encoding. For example, in the AWS, they have both x86 architecture. They also have ARM, like Graviton 2 and 3. So when this customer, they're very sensitive to the clouds. And we would like to try to leverage also relatively low cost, because then we are a commercialized company, so we need to earn revenue. But then with that margin, lower the cost, we can also lower the price for this kind of customer, so that will help them to grow. This type of flexibility and scaling actually provide us a lot of possibilities to address this market. So this is what I like to address at this moment.
Interesting. So what you're saying is that the cloud gives you optionality because, for example, you could use an ARM-based instance. Mm-hmm. You also could, again, in theory, if you needed, use a different type of architecture that you're probably not going to go, if you own your own infrastructure, and Suresh, you would get this, you're not going to say, oh yeah, I'm going to build out, for different use cases, different workflows, all these different machine architectures. Maybe you do that, maybe not. But so for you, scale then is almost optionality, right, Zoe?
Oh yeah.
I mean, it's having options.
Yeah.
And that's a perfect lead-in then to how does Dish think about this, Sling TV?
Sure. It's a very interesting topic, and it draws upon a conversation that we had with our leadership team in a casual conversation. The conversation led with a lead-in question. The question is, and maybe I'll pose this to the audience too, which is, what is the hardest thing to do on the internet? Wild guesses?
Trick question.
The hardest thing to do on the internet is to deliver video, right? So that conversation grounded us as engineers, architects. How do we do this at scale, elegantly, continuously, thinking of the last 9 from a reliability standpoint, and so on. And it's a cloud-native architecture that we are thinking of, that we want to lean in. And there are multiple dimensions and aspects of that cloud-native architecture. One dimension is, how do you scale up delivering thousands of channels across multiple bit rates in the bitrate profile ladder, different types of encoding techniques, integrating with different DRM flavors out there. Now, there is a lot of complexity that comes into this video processing workflow, all the way from your source content, encode, segment, transcode, push it to your origin, upstream to your public CDNs or your private CDNs, and finally to the end devices. So cloud not only brings the agility to support this or the ability to support it, but it also allows us to transform what I call these always on workloads, which is why I say that the hardest thing to do on the internet is to deliver video. When you have a workflow that is always on, is constantly streaming segments of data, like in 2 seconds or 3 seconds of segments, right? In such cases, how do you introduce the concept of like what you would see like an experimentation in a modern world, right? In a digital platform, right? Things like that. The ability to do small, incremental, continuous deployments using your pipeline. It's one thing to deliver a DevOps way or a continuous deployment way for your services. It's a whole nother gamut to do it for these always on type workloads, especially these black and what we call as the plumbing or the streaming services. So cloud is by default the way to approach your scaling, and it's just not being in a concept phase. A lot of players are adopting this. Even this morning, there was an announcement of an international content provider who's adopted Google Cloud as a platform to run their entire streaming services suite. But that said, it's got to be a fine balance in terms of the reliability, the performance, the scale, the latency that Zoe talked about, and combining that with a cost optimization way, right? So that's my thought to scaling.
One comment too, just to make, for anybody who's not familiar with Sling TV, and maybe this is obvious, you are a live linear service. You are a virtual MVPD, and so, Suresh is talking about continuous, and are you free to say exactly how many channels you operate?
Oh yeah. So we operate about 1,000 plus channels. In fact, on Feb 9th of this year, which was the 8th birthday of Sling TV, we call it as the National Cut the Cord Day. We launched our fast version of a product called Sling Free Stream, 300 plus channels on the fast category. And then obviously we have a ton of channels on the our packages like Sling Blue, Sling Orange, or the combo, and then a lot of add-on packages. So we run about 1,000 plus channels. So the scale is massive.
Yeah, this is always on.
Always on.
Never off. Yeah, Rob.
So when we think about scale, we start thinking about you use a scale for weight. So the weight of the resources that are necessary to deliver a service, whatever that service happens to be, to an end consumer. And the scale, depending on which part of the service you're talking about or which part of the delivery network you're talking about, can mean slightly different things. So when you talk about the actual physical infrastructure, the pipes to get there, the scale may be more around the latency aspect or the actual throughput. When you take a step back and you look at whether public or private type cloud workloads or the physical infrastructure, you may be talking about logical architecture constructs with CPU, memory, disk space, things like that. But one of the really interesting things that Suresh just said was that you have to operate at scale, which means that all of these different places within what your delivery network looks like and what you're actually delivering to the end customer looks like has to be continuous and has to match all the way throughout. Otherwise, you start getting bottlenecks and things start getting messy in their design. So when we start talking about public cloud or what most of our customers are leveraging today is hybrid cloud, some type of a mix, your scale ends up being this polymorphic thing that can burst and move the applications in a cloud native fashion or a disaggregated and where you're taking the individual applications and pulling them apart. So now your scale can move around depending on where you have opportunities for extra capacity. And so this is where our customer base is coming to not just Red Hat, but various foundations to learn how to disaggregate and how to pull these things apart in a way that simplifies it in the long run, but it's a sometimes a little bit of a journey to get there. So with back to the original concept of scale, and we'll talk a little later about how to scale. We want to start thinking about what scale means at each point within the network. So that's kind of where we start from.
Yeah, very good point. I think it's appropriate then that we talk about, I'm just assuming, with a group like this, there's probably folks who are building fast services, maybe traditional SVOD, file-based, and then live, like virtual MVPDs or other variations. It's all of those workflows have different requirements. So let's just really quick characterize what are the differences, between them when we look at kind of the end to end, but specifically that portion that we're going to be operating in the cloud. How do they differ? Where are they the same? What are some of the commonalities? And then that's probably a great place to then go to like the optimization layer. How do we then, within each one of those respective workflows, reduce costs while retaining quality? Because at the end of the day, that's, we can reduce costs, but we also can't sacrifice user experience and, the quality we're delivering. So who wants to, maybe give a quick characterization of?
Sure. I can share some insights there on the difference in the workflow between a linear content versus a file-based content, right? In the case of a file-based content, right, you're storing the content from the provider. It goes through the chain, which is like, you ingest, you distribute, you deliver, and then there is a caching technique too. A lot of common techniques that we use today is when the first customer in a region actually starts playing out, then we cache it at the edge, and then subsequently the next follow-on user or a customer who is playing out the content benefits from that cache at the edge. Whereas in the case of linear TV, it's very different, which is like it's real-time source feed that we get from our programming partners. We get it into our private cloud or public cloud infrastructure, and then from there, the streaming starts happening, which just goes through those encoding all the way to the delivering to the edge of the CDN. The first few steps are very unique based on the characteristics of the workload, but as you go up in the chain of those streaming service, you will see a lot of commonality with regard to the steps that is involved. What also complements is how do we get this metadata that allows a customer to search for their favorite content, in terms of finding their favorite content, consuming that favorite content, and then you also want to start giving recommendations like engaging and so on. So there is a very tight affinity between the actual physical content and the metadata that helps drive that engagement. So there is a lot of opportunities there in terms of making sure that there is an eventual consistency between both, and hence you give the right experience and the targeted experience for our customers.
Now, Suresh, you do have on-demand files, right?
We do.
You have an on-demand library. So are you saying that fundamentally your streaming workflow looks identical for the on-demand versus the live? The only difference is whether it's a file that it's retrieving out of a storage bucket somewhere, or if it's a HTTPS,
Yes.
live stream.
Technically.
Technically, that's interesting. Okay. Yeah, Rob, any further from your perspective as, foundation, the plumbing?
Yeah, it's definitely getting into the plumbing at that point. When you start looking at the construct of the storage itself or the compute required to run the encoders and the transcoders, it comes down to not only which aspect you need that particular piece of compute to handle, but it also comes down to how much you want to pay for it before you start potentially impacting the customer or the subscriber experience. You can get exceptionally good hardware in public cloud. if you're willing to pay for it continuously versus bursting something. This is something we were talking about the other day about having your live content, potentially burst into the cloud while it's running, but then when it turns into an on-demand or something along those lines, pull it back into your own house so that it's a little bit more of a controlled cost. With some of the providers that are announcing that they're going to go fully into a public cloud, I think it makes a lot of sense initially because you don't have that initial startup fee. They already are, the public clouds, the hyperscalers exist to be able to provide that hardware turnkey on day zero. So you just sign up online, you click the button, and you have it. Downside is that you start paying for it. And over time, those costs can ramp up, as I think a lot of other industries have seen.
Zoe, I'm really curious what you are doing and how you're working with your customers, because I can see a scenario where if I'm doing VOD encoding, I may or may not, I probably care somewhat about turnaround time.
Yeah.
I don't want to get the file in 28 days, but maybe I can get it in 4 hours and that's fine. That's very different, and that enables you to use less expensive instances, or maybe go to, the various public clouds have schemes where, when there's excess capacity, you can get it for sometimes half the price or even 60, 70%. Versus live, where you can't do that. That machine has to be there. Those resources have to be there. What are you doing, and what are you seeing? Are you getting involved in making those decisions, helping your customers?
Right. So we're talking about VOD and live, and then VOD and live definitely, as Mark mentioned, everybody mentioned that there is a latency down there. So usually VOD accommodate longer latency, but live, everybody know that. Even though you're saying with sometimes maybe up to 30 seconds, and sometimes it has to be lower than 1 second. So live is always, there's something, especially when you start streaming, you cannot stop. And then the latency down there has to be consistent. So even back to VOD, there's a different customer has different, because ultimately the user's experience, how we watch video, right? And then we like to experience. I think no matter where the customer, the user is, everybody want to enjoy the best possible video experiences. So let's just take VOD as an example. So for some VOD, actually, for short video app, because just now the panel before that, there's a Facebook, and then they have their short video app is Reels. So for this kind of VOD, there's still turnaround time. So if you have captured the video, you want to share with your friends at minimum time. So at that time, for what we are supposed to do is we can get a faster solution. Immediately get that video start to distribute. So this time it's actually sacrifice a little bit of the coding efficiency, meaning that the quality may not be ideal, and then the bit rate may not be ideal, but then the processing speed has to be ideal because you want that video to be shared with many. And then there's always a monitor. For example, during that platform, like even YouTube, there are always some very welcome host where you monitor that some videos are very hot, so like marked as most viewed videos. So at this time, you really want to get that video to be even better. So here, you may get another round of transcoding. So here, you may want to get a little bit more cost invested and get a little smaller, slower, but you really can squeeze out more bits and really boost that quality. So this time, you may, because you already have the previous version get to the users, but then the video become even hotter, and then same thing with subtitles in the OTT world. And this time, by spending more time, more computational resources, you get an ideal file size, very small, and with very good quality, and hand over to the end users. So it's very nice. On top of it, what you can do better, because some of the videos, like short video, when they're up to the cloud, there is still some artifacts, maybe already some blocky artifacts, but you found this content is very hot. What I can do further is not only you try to squeeze out bits, you can actually leverage, everybody talk about AI. You can add another layer before the encoder doing the enhancer. And this is not just only we are doing. A lot of people are doing that because you can use the AI machine learning to actually create some of the content that's not there. For example, they may have already the artifacts, you can remove it. They may have lower resolution like 360p or 720p. You can use a super resolution, machine learning based, and you can leverage the underlying not only CPU but the GPU to actually boost up the resolution from 360 to 720, from 720 to further boost to even 1080 or 4K. So there's something down there. So you sacrifice the computing resource, but you create a great content. Of course, the bitrate will be higher in that sense, and then but you really enjoy the good quality. Another layer before that, because we really want every video to be like that. However, the video has a large variety, meaning that if the video is already in good quality, you don't need that enhancer. You can just directly go with the encoder to directly distribute that. Or there's some video that is not as good. No matter what you do, there's no magic unless you change from one phase to the other completely. That's the different ones from what we are talking about. You still want to see, let the user see original content, but the quality is so bad, you don't want to do that. So here you may add another layer before the enhancer. So enhancer before the encoder, another layer before you leverage the AI to do some categorization. So meaning that you return the video without knowing originally how it looks like, you leverage the AI to identify there's 3 categories, good, bad, or intermediate. So only identify those intermediate videos, you say, okay, I have the room to further improve that, invest my computation costs, and really boost up the quality. So here's just an example, meaning that what we can do through all these strategies, leveraging different technologies, you hand over the best ideal video quality to the users, but really based on the different use cases.
You know, it's really interesting as you're talking about that. We're all hearing about personalization, right? In my mind, it's almost like personalization of what that video needs. And of course, you're talking about more user-generated, where you're not in control. I mean, you know, Suresh, you have pretty good. Most of your content falls well within, you know, some broadcast standards and all, yes. But not everybody has that benefit. And so, you know, what Zoe was just talking about is this amazing capability that using, you know, AI and using more advanced codecs and just more advanced processing schemes, and then with the cloud, the fact that the cloud can so easily flex, you can deliver, you know, you can spend the compute resources where you're going to get the best return on that. And I think that's clearly, we're seeing a lot more workflows that are starting to migrate. Now, I think there's still a lot of that's a little bit theoretical and a little bit, but yet it is being adopted, and I know it is. If anyone, you know, and this is kind of an easy example, Jan Ozer actually did some extensive analysis on this, looking at YouTube and which videos they encode with AV1. And it's very, very easy to see that once it hits a certain threshold of views, that's when they create an AV1 encode. And you could say, well, why don't they encode all of them? Well, I think at this point, they're doing that in software, not in hardware. And so there's a compute cost. So they just simply run the numbers, run the math, and say, does it make sense, you know, below a certain number?
I want to mention a trick down here. It's just if you look at the video, you can actually look at to watch YouTube on your phone. But just in case you watch on the laptop, right click on top of the video when you watch YouTube. There's a stats for nerd.
Yeah.
And then when you turn on that, you actually be able to identify the underlying codec. So okay. Usually there's 3 codecs behind that of YouTube. I won't take too much time, but it's just you can try the trick. Right click, stats for NAB. There's 3 codec, VP9, AV1, and 264. And then 264 has another name called AVC. So there's 3, meaning that just follow what you mentioned. If you click on top of some videos really hot, you look at maybe more than already 1 million views, then you'll be able to see 81 down there. And on the other side, maybe mostly VP now 2, 3, 4. So because I talked to some of the kids, because my son is 12 years old, 12th grader. So I said, if your friends really think they are very popular, right-click and look at whether it's encoded by AV1. So that means that is really popular.
That's the hack. No, that's great. So what parts of the workflow are more easily migrated? I think the conversation is, I always like to provide as much value as possible to the audience who's giving us their precious time. And so on one hand, even the discussion we've had, super interesting, maybe relevant, but probably people are grappling with, I'm either, I'm thinking about migrating, I'm not sure where to start, what should I migrate, because it's not like a light switch. You don't just say, oh, I think, over the next 60 days, we're gonna move everything to the cloud. I mean, just isn't that simple, at least for most of us, right? So based on your experiences collectively, I think it'd be super helpful to share, what are those functions that are easiest to say, hey, actually it's relatively easy, go spin up on an instance, and within a short period of time, we could start running that service in the cloud.
Yeah. Different platforms, different architecture patterns, different mindsets, different ways of implementation. There is no straight answer to this, but can all of the workloads be migrated to the cloud? Absolutely yes. Which ones do you want to go after, right? Like we've looked at encoding. We run it on Kubernetes. We are also thinking of ways in which like a channel can be running on a Kubernetes pod. And today it takes a lot of, by default, it brings a lot of automation to the table. Now, when you have one source feed go down, you need to pivot to a different source feed, like a backup source feed. Kubernetes can automatically help you achieve some of these capabilities, and we don't want to program to some of these things and spend a lot of developer cycles. So we want to look at where the puts and takes are. We also want to look at, closely from an observability standpoint, right? There are a number of metrics that we can look for from a performance, reliability, and capacity standpoint, and look at migrating some of those workloads. We've started with encoding as an example.
I think that the secondary kind of follow-up thing is it depends on whether you've built a lot of that in-house, or if you're using a network of ecosystem vendors that are providing those technologies. And you may want to start by canvassing your ecosystem partners and say, have you guys already tried this? Because in some cases, they've already done some of the heavy lifting, especially if you're using a complete stack from a particular vendor, and they may look at it and go, well, yeah, so the encoder is ready to go, perfect, we're good to go. The packager, there'll be dragons. Let's leave that alone. And it may also take a little bit of nuances as to how you have implemented, because let's face it, even if you're using a complete stack from a single vendor, you still have some of your own homegrown pieces to help glue it all together to make it customized for your end user experience to differentiate from your competition. So it's gonna take a little bit more nuanced planning, and that planning is gonna take way more than just the technology. Because when you move into that cloud native microservice based world, you get into asking the question, does this application still do what I originally intended it to do? I personally started my career as a systems administrator, which meant I spent most of my time trying to replace myself with small Perl scripts. I guarantee you, if you go back to Appalachian State University's IT department and try to find my Perl scripts, they're probably still there, scary enough, but they're definitely not relevant. And I don't wish that upon anybody. But I still think that planning from the process standpoint, as well as the people standpoint, becomes incredibly important to that cloudification journey.
This reminds me of the workflow reminds me of the game of Jenga, actually, in a way.
Oh, yeah.
It's like, you pull a stick out of that, but I might be changing the rules of Jenga here for a moment, which is like, you modernize that workflow, cloud native enable that workflow, and bring that stick back into where it is, or bring it to the top of the stack, and that's how you gradually modernize. So the sticks that you look at the top looks more modern and more visible, and the ones at the bottom are like, ready for prime time, which is like ready for being cloud native enablement.
Yeah.
And they may not even look like sticks anymore.
Yeah, that's right.
I think we benefit from that as well. I just think about one like OTT customers hours, because we are always been doing, I think we're very proud of our encoder, but there's a lot of other things to learn. And then for this customer said, before we really want to deploy, they already done all the evaluations, said we have to go with DRM because they are OTT. And then previously, of course, by that time, we have done a lot of UGC, and then those customers do not quite care, but then this customer really care about DRM. We started to do some like homework, and then we found there's so many different DRM vendors, and we have to work with them, but we really not want delay because that customer really want to get online fast, and we were a little bit nervous. Then we finally were recommended by one of our team members, say, hey, AWS has a Speak, SPKE, that basically have the common interface. As long as you make your transcoding really align with that standard, then those DRM vendors, if they do not align with that, you actually should not consider. And then if they are aligned, actually it's made things a lot easier. That's what we finally proceeded with, and also impress our customers as well as their finally they chose their own DRM vendor. So what I meant is at this time, because the two panelists mentioned about stack, and then with all those common, I think, agreement protocols defined, and then the cloud really become you just focus on your own blocks, and for all the others, I don't want to take too much, but here is some customers think they want to do live, but they cannot deploy directly our live encoder because they cannot really just deploy one module. They want us to provide sort of end-to-end solutions. And then we found that over the cloud, it'd be relatively easy for us to get the package like HR space and then hook up with the potential CDN. Of course, this is some other work, not as easy as it's just as I said. It still provides you a lot of possibilities with all these different blocks being provided and those common APIs being defined, and a lot more. It's in the end, it's easier for us vendor. It's also a lot more convenient and still provide the best possible experience for our end users.
So how does the panel recommend making a decision? Because we talk about the public clouds and, they all have kind of this ubiquitous infrastructure. The reality is that some of them have very developed, applications. You could call them microservices, and we'll try and remain nameless. So, but there's some Amazon, which has incredible building blocks, right? Yep. And then all the way to others that it's basically bare metal that's incredibly cost effective. So, and then there's in between, right? How does someone decide? Because on one hand, it'd be easy to say, well, geez, if I go with this particular vendor, they've got all the building blocks. We have to do a little bit of glue, but we've got a working solution. Otherwise, I have to fully deploy and build my software stack. Rob, I'm going to start with you because at the end of the day, largely that's what Red Hat and what you guys are helping with, right?
Yeah.
But talk to us about the trade-offs and the decision matrix there, because I don't think it's so simple. You can back yourself into the corner, right?
It's certainly not simple, and I think you bring up a great point about potentially backing yourself into a corner with the solutions that are a little more well built and put together. You are effectively adopting their recommended ecosystem, their best practices, the way that they have determined is in some cases, the best fit for you, but by and large, the best way for them to support you in their business model. Because let's face it,
This is key.
Yeah.
Repeat what you just said.
So we talked about, and Suresh brought it up in the pre-call, about this concept of technical debt. And within that concept of technical debt, the more you end up in that ecosystem of doing things just because it happens to fit a particular application stack, regardless of what it is, you end up potentially getting fully vendor locked into that solution. The catch is that all technical debt isn't necessarily bad, as long as you can account for it and you know where it is in your environment. When you don't know where it is and you decide you would like to make a change, that's when things get really, really expensive. Now, the flip side is to go to something that is completely clean slate. You know, every cloud vendor has to offer things and APIs that are based at least loosely on open standards. So making sure that you know what those open standards are as you start building things, and we see a lot of organizations go with a complete DIY mentality, which ends up in a situation where now not only are you responsible for the Kubernetes, which is just one piece of that stack, there's, you know, potentially a minimum of like 17 to 25 other applications just to make it do something useful for the enterprise to get everything put together and make it work right. So, and that's lifecycle operations, monitoring, logging, things like that. So you really kind of have to do a lot of that planning process that I mentioned earlier to get it all ironed out. And that's where, again, going to your ecosystem partners and saying, what do you support? Because if you start doing unnatural things and you're not a ultra mega tier 1 provider that can dictate to the industry what they do, working within that ecosystem is going to be incredibly important. But still making sure that you've taken the time to, not only from an operations perspective, but also from a cost modeling perspective, understand what those different knobs and buttons are going to do as you try to make change and as you try to, from the first question, scale your environment both up, out, as well as back down when certain things happen.
That's great.
What he
Suresh.
said, really resonated well with us. Is the planning process is so important, right? And the key to this is the mindset of experimentation, right? It's the mindset of experimentation where we can run small experiments, right, in any environment at a very small scale, like the atomic habits, if you will, right? Like, and getting all the real KPIs and data and comparing and contrasting with other experiments and choosing the best option. And that's where the MLOps and the feedback loop also comes in, and it takes us to the next level of elevation, but it starts with an experimentation mindset, right? Because at that point in time, you are really taking data-driven decisions, right? Which is extremely important, as opposed to taking decisions based on a PowerPoint or a paperware, and imagine funneling millions of dollars of investment and then coming back to the table again and saying that, hey, I should have gone with plan B. Instead, we start with an experimentation. You have data, you take decision based on data.
And we're actually doing some of that and taking that one level further, not quite to like AI, ML, but with closed loop automation. So taking those small experiments, using the data that comes off of them, feeding them back in, and letting the system kind of take care of itself with some very, very hyper-specific ways that we have determined are safe, with obviously some exit loops and things to make sure it doesn't get too scary. But that's kind of the next iteration of that journey that we talked about a little bit ago.
That's awesome. Any questions? You have an incredible group of experts here, so don't miss the opportunity.
I add one point based on that. I learned quite a bit from my
Feel free to come up to the microphone.
co-panelists. And then, so regarding the experiment that we actually have done quite some experiment, because I would say every single year, every single month, and we are growing. And then a lot of, I think the number of course for me, I'm grateful for the team, but then here is really grateful for the customers. So here's the thing, you want to be able to like really experiment with the customer, because no customer really want to be the first one to take that. However, you always have existing customer that you already built trust with. And then usually they will grow new requests. At this time, they prefer you as the vendor to their new request. And this is a golden opportunity. You can do the experiment, because after justification, we can provide the product to address new request, and then we don't have a mature product yet. Because every product, I would say that no matter how you plan, how you think you will design and develop, when you really put that product serving a customer, there's all kinds of different issues that you never sometimes expect. So we really appreciate that. That's what we do. For example, originally we mainly have our cloud-based transcoder over AWS, and these customers say, okay, they want to use the API, but they have to be deployed over GCP, no AWS. That's their choice. We here do not want to just choose one or the other. And then we're also grateful that because I think all the cloud, they actually provide similar similarity. For us, it's not too hard. Actually, just within a week, we deployed our whole solution over GCP. But at that time, we have not experimented with the GCP yet. So thanks to our customer that gave us the opportunity. From then on, we said, it's always the first time is the hardest, right? The second time, you can just claim, I'm the expert right now. What I meant is there's a lot of things that we want to see that experiment. For us, we try to avoid the opportunity cost, meaning that if we get some product and then finally start to look for customer, we found, wow, this may not really address the customer needs. And we cannot quite afford, there's always something, but we try to avoid that. Listen to the customers, doing experiment with them is really what we have achieved quite a bit.
Any questions? If not, I have one more.
You got prepared.
That's right. Okay. Cost reduction. 2023, the year of trimming budgets, right? So what are some strategies? I think at the, what did you call it, Suresh? The Uber tier 1 user or whatever. So there's a certain class of customer that can, go out there and negotiate and can, even say, well, we're going to, use these guys for this service but for the rest of us, maybe you can share some thoughts or, real world, that's even better, on how can we reduce costs? And, there's also a move now to, in some cases, moving off the cloud and even going to on-prem. Does that make sense? And if so, when?
FinOps is at the center of everything that we want, that we plan, that we want to do, that we want to execute, right? One thing where the industry has helped, like with partners like Red Hat introducing their OpenShift platform, so it has leveled the playing field with Kubernetes, right? So I can run different types of workloads. I can run the same workload on-prem and then expand into public cloud, right? Then you have these concepts like Kube Edge, right? Where you bring in resiliency or, a capability to run a workload on a Kubernetes pod on one part of Kube Edge, and then you can expand it at the edge as well, right? There are multiple options out there, and it allows us to slice and dice and find the most efficient way. And it goes back again to that experimentation, which is like when you run it on 1% of the workload, you can workload model to see what it looks like at 100% from a scale performance and even from a FinOps standpoint perspective. So again, it goes back to that, experimentation and the data that we collect. Today we run some workloads, on-prem in a private cloud and some on public cloud. It's a cautious decision that we've made based on what makes good sense from a customer experience standpoint. From a reliability standpoint, we take pride in saying that reliability is our number one feature, right? And then obviously you also want to counterbalance that with the right efficiency in terms of cost FinOps standpoint as well.
So the only kind of thing that I would add to that is that you also have to keep track of where you're spending the money that doesn't expose you to risk. Because if you get too lean in certain areas, we have found that our customer base can find themselves in supportability challenges. So you basically end up with two of the lower cost type options that don't necessarily play well together, and now your engineering cost goes through the roof because you're trying to make them work together. And so another component of this is trying to make it so that you can run not even hybrid cloud, but multi-cloud. If you're trying to move workloads between clouds to get better cost modeling, and you're doing it too quickly, and you're doing it in such a way that you have to modify between the clouds, then is that really an added benefit or is it not? We've found a way, or we found a few ways to coach our customers to make sure that within those not just open source but open standards, we can ease that process and make it as seamless as humanly possible and provide that benefit transparently to the end customer, the end subscriber, in such a way that not only does the end subscriber not notice, but the internal customer doesn't even notice, because now all they're focused on is the application itself.
Yeah. That's great.
So my turn. It's because our product with encoder, and we save two costs for the customer. One is the seeding cost, because we try to squeeze more bits, and definitely have the seeding cost down there saving. On the other side, we try to optimize our algorithm, better quality, lower bit rate, but also use as least CPU cores as possible. So that's also saving the cost on that end. So of course, there's still room for us to optimize that, because there's a new codec come out, there's new room for us to optimize. But I want to address one thing. We really feel the saving cost for the past, I think since roughly April of 2022 up to now, because we feel that the customer also say, hey, can we renegotiate the already multi-year contract because they cannot afford. And then we start to calculate, saying that how much we can save, we still worth that, but at least you can reduce the price. What we feel like, I think the request. I want to give one example. And everybody knows Zoom. And Zoom was really boomed over the pandemic. Of course, they went back to, I think at least stock-wise, to the pre-pandemic. But still, a lot of you can ask a question, why Zoom, that you are willing to pay the monthly fee to subscribe Zoom? Because Zoom let everybody know that for internet video conference, because I once at HP Labs, that was back to before 2010, I was always involved in that called Halo video conferencing system. So at that time, we believed that if you want to get a good video conferencing, you have to have those fiber-based cable. You have to get those really equipment. You can't imagine there's one day just based on the phone, your laptop, you can enjoy very nice visual experiences by Zoom. So what I meant is we are all human beings. We want to have a good life. So when the new requests come out and the technology driving to let people really see that the technology make that visual experience possible, there will be some new requests that not only Zoom, right? There's so many people are willing to pay for that. So in return, because we are doing startup meaning that you really want to get a bigger market. And we found that the market is really evolving. So everybody right now talking about GPT. And everybody use that. For us, when we start, because startup meaning that we already make profitable. This is not, we don't have to rely on fundraising. But on the other side, there's also said, oh, investor also tight their pocket. They don't want to fundraise because everybody is saving cost. However, you look at GPT, you look at so many new startups right now doing GPT related big model AI startup. So suddenly realize, and then you can see that all the investors chasing after this. And I heard it's a crazy thing is that in one project, their valuation increased double for every 3 days. So there's still things there. Why? Because the GPT bring up new requests. Same thing is we already look for how we encode those so-called AI generated content. Because nowadays, I know that my husband is trying to say whether the AI can generate something just like those great artists produces the art, but really just capture something that about him. You can tell it's him, but it's like already an art version of himself. And we see videos also created this way. Because this way, we found there's something new we can do. This is not because what I meant is when the new requests come out, maybe we not have to talk about cost saving. We are to actually push the whole economy. What I meant is in return, there's a lot of new requests for how the cloud provide, because right now, every single public cloud, I knew that they try to chase after what OpenAI is doing, because they know that they have to provide this kind of capability. Otherwise, they always data, because it's a big data that has to happen on the cloud, at least this moment, because it needs tremendous GPU type of computation happening on the cloud. And also you have to consider this is big data driven. What's the security? How do you try to avoid the leakage of this kind of data? So the cloud is also evolving. Almost all my friends working on the cloud, they have to work on this.
Cloud's evolving. That's a
this
good
is
point.
So what I meant is we hope 2023 will be it's definitely already. It's because of GPI. It's going to be a year that's going to be marking the whole history. So cost saving is always there, but new requests will always appear so that everybody enjoy. And the one thing is, I just want to say for us, because we're a startup, and I'm the founder, so we need to keep learning and keep growing, and then the world will be really beautiful down the road.
Yeah, that's great.
Talk about learning. One thing that the industry has done a really terrific job of is, especially on the video workflow, is doing more with less, right? Like as you think of solutions like low latency HLS, the payload size is becoming smaller and smaller, and hence you can do more with less. And it goes back to that concept of how we can be lean, nimble, and quick.
Yeah.
Especially for always on workloads, doing more with less is just a developer's delight.
Yeah, that's awesome. Well, on that note, and since we are 1 minute away, I'm going to wrap it up. Thank you very much for joining. We really appreciate you giving us your time. The panelists, I don't know, are you guys going to be at the cocktail party?
Yeah.
Yes.
Yep. Okay.
Absolutely.
All right. So if you're going to join us, then you can chat with them. And yeah, thank you again.
Thank you all.
For everyone.
Thank you.